Question 2. There are 3 capacitors that are connected in the battery as shown, C1, C2, and C3. They each have different capacitances. This one is 3C, C2 is just C, and C3 is 5C. Okay. Part A, what is the equivalent capacitance of the set of capacitors? Okay, so we need to look at that one. So for part A down here, I'm going to look and see what I can simplify here first. These two stick out to me, being that they're in parallel. I can take and I can cut this circuit off here, and I can remove those two parallels and make a equivalent capacitance out of it. Okay, if I do that, I'll be left with the 3C up above, and this one will now be some new capacitance. Okay. The new capacitance here, being that these are in parallel, they will just add together. So I'll have the 1C plus the 5C, and I will get 6C. Okay, using the laws that we have. Okay, then if I want to continue along, I can then combine that further into a single capacitor, because I can see that this 3 and this 6 are in series. Okay, when 3 and 6 are in series, the equivalence capacitance here will be 1/3 plus 1/6 to the -1, or to the 1/C equivalence. Okay. When we get there, when we add up, you can, if you like, you can make this 2/6. 2/6 plus 1/6 gives me 3/6, or a half. Inverse a half, and we get 2. We get 2C. What was our equivalent resistance on here? Will be 2C. Okay, like our picture shows, or our answer. Part B, state the ranking of capacitors according to the charge they store from largest to smallest. Okay, so we're looking for charge. Okay. If this is some voltage V that is being put across here, we can use our C is Q over V. And we can say this is the capacitance here. Let's just say V is whatever V is. That means the charge that's on this will be Q, or the charge Q will be C times V. C times V would be 2CV. Okay, so I'm going to figure out what the charges are on all 3 of these, and then I'll work backward. Okay. Working back from this one, this was made from a series, okay? And in a series, the charge remains the same on all the plates because they're connected in the middle. So which means the charge here must be 2CV. The charge here must be 2CV. Okay? So I've got the Q. I've got the Q for this top one. I'll have to figure out where this one came from. Okay. So this came from these two, which were in parallel. In parallel, voltage remains the same. So I have to figure out voltage on this one. So V would be Q over C. So if I put Q over C, the C's will cancel, and I will get 6 over 2, which is 3V. Okay. Sorry, no, that is incorrect. If I put Q over C, I will get 1/3 V. 6 over 2 will become 2 over 6. And we'll get 1/3 V is equal to V. Now if I bring that back, I can see here that this was made up from here, so I know that these are C's. My V's are going to continue along, and the Q is what's going to be left. So this one is C. The V on this is 1/3 V. And the Q on this one is what I am looking for. This one has remained the same, everything from down here. Okay. So now I'm looking for the Q's on these, so I have all of my Q's so I can arrange them in order. Okay. So Q, if we look at Q, Q is equal to C times V. So C times V here is going to be 5/3 CV. And if we look at Q here, it's C times V, so we have a C times 1/3 V. So the Q here is 1/3 CV. Now if we arrange those in order, this is almost 2, but not quite. So Q1 from the capacitor 1 is going to be the largest, which we have over here. The next largest, of course, will be Q3 over here with 5/3. Okay, and then the lowest one here is at 1/3 CV. So that would be the lowest is Q2. Part C, rank the capacitors according to the potential difference. So now we're looking for V from largest to smallest. I have these. I have this V and I have this V already are the same. C2 and C3 are already the same. So all I have to do is figure out what the V is on the C1. Okay, so I'm looking for V. V would be Q over C. So Q over C. I'm getting 2/3 V. Okay, so being this is 2/3 V. Okay, this is greater than each of the 1/3. So voltage on the first one is the greatest, and then 2 and 3 are both equal to each other. Okay. Part D states, what if? Okay, so here's just a what if. Assume that C3 is increased. Okay, if we increase C3, what will happen to the charge between the capacitors? Okay, so if we increase the amount of C, okay, so we're increasing C here, the charge is going to have to go up, correct? Okay, because if we increase this, we'll have to increase this. We're not touching V, which means this will have to increase. So C, or the charge on 3 will have to increase. Okay. To get the rest of these, you have to think logically around the circuit. Okay, to see what happens to the rest of these. An increase on this C will cause an increase here on this C, because these are in parallel and they're going to get added together. That'll add an increase here on this C and virtually increase this Q. Okay, so if we do this, what happens to this, being that this is a cross? Or this is a series. Okay, which tells me that Q1, being this Q, will also increase. If these have gone up, this shares the same Q, which means this must also increase. So Q1 will also increase. However, Q2 though, Q2 will end up decreasing down. Okay, Q2 decreases because the charge here and here, okay, are shared amongst this 2CV. So if you increase the one, the other must come down to suit it. So this one might take a little bit of thinking to try and wrap your head around. I know I go back and forth on it, but it's a what if question, that's all.